Okay, let's say we have a coordinate system like this. This is y, and this is x. I'll put that x out here, y like that. And we're going to launch a projectile from the origin at some angle theta with respect to the x-axis. We'll call that angle theta, and the initial velocity we're going to call v0. And we know what happens is that the projectile makes a trajectory something like this, and it ends up coming down over here at the same altitude from which it departed at some distance delta x away from the origin. That's what we want to find. That's called the range of the projectile. Say that delta x is equal to r, the range. So what we have to realize is that what happens in the x direction is independent of what happens in the y direction. And I'm going to write what the y component of the velocity is. This is just equal to v0 times sine theta. And the x component of the velocity, this part right here, this is just equal to v0 times the cosine of theta. So if we knew how long this thing is in the air, and we multiply that times the x component of the velocity, that would give us the range. In other words, the range, delta x, is going to be equal to v0 x times the time of flight. And the way we can find out the time of flight is to write down the equation for what happens in the y direction. And what happens in the y direction is that the projectile goes up, comes back down. And we can describe that motion with this equation. Y of t is equal to minus 1/2 g t squared plus v0 y times t. And if we set this equal to 0, then this equation can be simplified by dividing through by t to get rid of that one, get rid of the square, and then I can rewrite this as 1/2 gt is equal to v0 y. And that means then that t, the total time of flight, is equal to 2 times v0 y over g. So therefore, delta x is equal to v0 x times t, which is 2 times v0 y over g. Or, let me push this up a little bit. Or I can write delta x, which is equal to r, the range, is equal to v0 x, v0 y over g times 2. So that's equal to v0 x, which is v0 cosine theta, times v0 y, which is v0 times sine theta, and that's equal to 2 all over g. And I can simplify this a little bit by writing that r then is equal to v0 squared over g times 2 sine theta cosine theta. This can be substituted by a trigonometric identity for a sine of 2 theta. So this is equal to v0 squared over g times the sine of 2 theta. So the range, horizontal range of a projectile then, is just v0 squared over g times the sine of 2 theta. That's where it's launched with an initial velocity v naught at an angle theta with respect to the x-axis, and it comes down at the same altitude that it took off from.